Today's enterprise applications place heavy demands on storage systems. A single workload may require terabytes of high-performance shared storage. Modern data centers are abandoning traditional SAN storage in favor of more flexible, hyperconverged infrastructure. Not all HCI solutions, however, have similar or equivalent architectures. While Nutanix employs an advanced distributed systems design based upon true cloud engineering principles, other HCI products retrofit old rigid SAN architectures onto an HCI form factor. In this video, we'll explain why having the right HCI architecture is critically important for real-world deployments. All HCI solutions aggregate the storage capacity of individual servers, which are deployed in a cluster, as few as 3 or 4, but often 20 or more. When storage resources are highly distributed, application data must be placed in the right location in the cluster for the best possible availability, performance, and system resilience. This is because, unlike SAN storage arrays, HCI systems use off-the-shelf servers and cannot rely on hardware to ensure high availability and fast performance. It's up to the HCI software. Let's look at an example. In a typical configuration, the HCI cluster maintains 2 copies of data to withstand the failure of a server. When a node fails, the data stored on that node is no longer accessible by the system. This puts the overall HCI system at risk, as the failure of an additional node or even single disk could result in data loss. The challenge for the HCI system is to quickly self-heal, to rebuild the lost data and bring the system back to a fully replicated state in the shortest possible time. So how does Nutanix handle a node failure? When a node in a Nutanix AOS cluster fails, the data recovery process initiates right away. Because the secondary data copy is distributed across other nodes in the cluster, every node participates in the rebuild operation, dramatically reducing recovery times and substantially reducing the risk of data loss. And even during the rebuild operation, AOS dynamically chooses the best available node for new incoming writes, so all new writes are always protected per the configured replication policy. Data locality is a very important HCI architectural capability, in which the system maintains 1 copy of data on the same node as the application. This enables applications to access data over a low-latency system bus, rather than a much slower network link. Data locality not only drives faster and more reliable HCI performance, it is an architectural requirement to drive maximum performance from NVMe drives or from storage class memory technologies like Intel Optane. Nutanix AOS is the industry's only HCI solution with a fully distributed architecture, able to maintain high performance via data locality, ensure data resilience in the face of disk or node failures, and increase reliability and performance as the cluster scales as nodes are added. As hyperconverged infrastructure solutions grow in popularity, IT leaders must look beyond marketing claims and investigate each system's core architecture. It's time to ask the difficult questions.